In this lesson, we're going to explore the scale factor and how it's related to the area. Notice in our rectangle below, we have length times width, which will give us the area of figure 1. The larger rectangle is a result of figure 1 with a scale factor of k. Well, if we want to find the area of the larger rectangle, we would go KL times KW. And then if we simplify this, it becomes k squared times LW, which means if we take our scale factor and square it, multiply that by the original area, we will get our new area of our scale drawing. On this next figure, notice that we have a large circle with a radius of 4, a medium-sized circle shaded with a radius of 2, and then 2 smaller circles, each with a radius of 1. It would like us to use the scale factors in order to find the area if we know that the large outer circle has an inner area of 50.24 square units. So we first need to use our scale factor. If we look at the large shaded circle, that has a radius of 2, and the area region that we know has with the orange radius of 4. So if we compare those, we would have a 2 to 4 ratio, but we have to square it because we're talking about area. So we'd get 4 over 16, or you could reduce to be 1/4. Then we have to do the same thing with a smaller circle. It has a radius of 1 compared to the large circle in the outer area there with a 4, so 1 to 4, we have to square that scale factor, and we would get 1/16. So now we need to figure out the scale factor sum of our shaded. We have 2 small circles and 1 large, so we have the 4 over 16 for the large shaded circle plus 1/16 plus another 1/16 gives us a total of 6/16 of the area is shaded. So 6/16 of the total area, since we know the total area is 50.24, we can multiply the 60/16 by the 50.24, giving us 18.84 square units is the shaded area. Now, if we continue, we'll notice that it asks us to find what percent of the large circle region is unshaded. Well, we just found the shaded region, so if we take the shaded region and subtract the unshaded region, if we take the total and subtract the shaded region, we will get the unshaded region, which is 31.4 square units. But they didn't ask us for the area, they asked for the percent. So we need to take the part 31.4 and figure out what percent that is of the 50.24. So 31.4 over 50.24 times 100 will give us 62.5% of the large region is unshaded. In question 3, we are comparing 2 rockets, one that has a height of 20 centimeters, the small rocket, and the large rocket has a height of 120 centimeters. They would like us to figure out what percent of the area of the smaller rocket is the area of the large rocket. So first we need to figure out the scale factor between the heights. So if we compare the 120 to the 20 centimeters, the large height to the small height, we will get a scale factor of 6. So that scale factor of 6 tells us that to find our area of the large rocket, we can square our scale factor and multiply it by the area of the small rocket to find the area of the large rocket. So if I square 6, I will get 36. So the large rocket is 36 times larger than the small rocket. This would mean as a percent that we'd have 3,600% of the small area would equal the large area because it is 36 times bigger. So the percent must be greater than 100. In question number 4, we're given a photo frame with 3 5-inch by 5-inch square cutouts for photographs. If these cutout regions, all 3 of them together, make up 3/16 of the area of the entire frame, what are the dimensions of the photo frame? So we're trying to find the dimensions of the photo frame. Since we know the area of the 3 cutouts is 3/16 of the entire frame, and there's 3 of them, that means if we divide by 3, we'll know what one of them is. This means that each would be 1/16. So the area of the drawing here is 1/16 of the original area. So that cutout, each one of those cutouts is 1/16 of the original area. Since when we talk about area, we square our scale factor. So our scale factor squared equals 1/16. Well, that's the 2-dimensional factor that we're multiplying by. I want the 1-dimensional one. So what squared would equal 1/16? So since 16 is a perfect square and 4 squared equals 16, then the number squared that equals 1/16 would be 1/4. That means our scale factor for our 1-dimensional measurements, like length or width, is going to be 1/4. So each of the dimensions of the little cutouts are 1/4 of the length or width of my original square. So since we know that it's 5 inches there, we know 1/4 of the original dimension of the square is going to equal 5 inches. So to solve this, I can just say 1/4 times my unknown x equals 5. And then we'll multiply both sides by 4 and we'll get 20 inches. So my frame is a 20-inch by 20-inch frame.